This is the just a simple file, simple video just to show that how we get all the data in a single file, that is tangent portion, point portion, and the curve portion. So we had already recorded some data, and I'm just giving you example from the same data which was already recorded. So I'm just clicking a file. I'm just opening the software file. Okay, the software is here. I'll just click this template which was already demonstrated how to do it. Then I just click open. I'm just taking a small file because if we take a long file it takes little time to plot the data in this. So I'm just taking this 184 meter section. So I just click on OK. So there is some more description of it. I just click again OK, and I just click recalculate. So it's a simple process basically. So if I just show in the same graph, you can just see there is some events. This red portion is showing you the event description. So I just zoom it so you can see, you just see this, there is a P06F. So this event indicates basically there could be a switch. So the event is not basically automatically generated. The user has to assign these events to bifurcate the data to make the data easily readable. So this may be if you just check, if using this for sign profile, you can easily take an idea that there is a basically small curve, and there could be a straight section, then after point there could be a straight section again. So a simple way, I just click file and just can export all the data in a simple file. There is no need to worry that a file cannot take all the data in one go. So it can take basically, but since if the user needs it in different format or different for curve, different for point, the different for tangent, so definitely they used to make some subsection, and subsection evaluation is here. This point was also in the demonstrated to the track team. Basically you just can click on subsection, you just enter the start kilometer, end kilometer, click here, and the section will be only a few section. Like if you need to make the curve data separate and the tangent data separate and the point data separate, so you just can take the data out from this using this subsection method. If required, we can just give a complete video on this also. So right now I'm just taking the exporting the data in one file. So right now about rail profile, I'll just go click on rail profile. So this is why I have taken a small file, because rail profile sometimes takes too much time to get calculation. So I'm taking a small file just to demonstrate. I click OK. So you just can see there is some deviation in the rail profile. I'll just especially in this software, because we noticed from our past experience that there is some rail inclination available in all the section of BMRCL. This I'll just show how to check it also. So I just click on merge. At first we'll click on merge. So after merging, the data will be merged with the measure data, and then click on vertical lateral angle. So the data will be calculated in the graph also. So I have clicked on, and now I again go to graph. I will just close this graph again and will open this graph again. So once you open it again, you will see that these particular two, railway lateral and railway top, is already filled up. Now you can just check so how the data is here. So you can just see that there is very minimum top wear, because uh, the inclination of particular this section is very good. So I'll just show how to check the rail inclination in this section also. If I just click this file, I close, I'll just show how to check basically. And the final evaluation is for local defects table. Again, I'll just close it. So these all tables have different meaning basically for the evaluation. So that is up to customer, how client, how they actually use to read the data and evaluate the data. This software is basically the evaluation software. And I just click here. So now you see there is a data, and as soon as I move my cursor here, you just see. And so the basically the angle here is the rail inclination, like this. So if I just check the rail inclination, particular in this section, there is a little bit problem, but uh, at least in whole section the rail is basically perfectly inclined, but particular this point it is not. So it is because there is a point, and point means because well, when we start measuring the point we need to change the angle of the camera. So it is up to the camera angle, because and the camera can be changed, the camera angle can be changed even at the time when we are already in between the measurement, so there is not a worry about it. So but user had to take care, because Trolley cannot not do it automatically. So because there is two angles to fix the camera, one is inclined face and one is on top, so that is why. So but user has to take care, because Trolley automatically cannot. I'm just repeating it. So now if I wish to to export this data to Excel sheet, I'll just click export and then export quantities. So I just need to, we have too many uh, points here what we actually need to export. So I just unclick a few which is not of our use. This is cant I'm using, alignment means sign I'm using, gauge I'm taking, twist I'm not taking, grad I'm not taking, and where I am taking, and events I'm taking. So okay, and this is the export step. So I just click here, and I'm just making a file for the same. I just click on desktop. I will name it data evaluation in one go. Click. So I just click here, data evaluation. So here it is. So now if I check, so here is the complete data of curve, then point, and then the state portion also. So whole data is there. Now I just click on close. I also would like to show one more thing here. Okay, so now taken the data. So if you see specifically for points, we also have one more different kind of form which can especially dedicated to the points only. So if I click here, I just can see there is some point: Bangalore Eastern, switch ID 319 boss, and starting change and the street section. I just click OK. So as soon I click OK, I'll find some data here, because this is basically the file which was taken on a point specifically, especially for the turnout inspection. So in turnout, the user must know that they specifically have some points, and these all points have some ID, like this P6 is having fifth sleeper, then P7 is on 10th sleeper, then we take more point, then P8 is on 15th sleeper, and on each sleeper what data we have taken. In particular this point we have taken gauge, cant, and alignment also. So alignment window, you can see it is not having any values, because alignment is basically calculated on a particular code. So if I click here, you'll just notice that all the particular system has been filled up, like word sign is now there, word sign is now there. So word sign and alignment is the same thing. So now I think it's very clear that there is no issue in exporting the file of having tangent data, crossing data, and the curve data. So there should be no issue in that. I don't think it is having any issue. So okay, now I close this.